Welcome to today's lesson on calculus. We're going to solve a problem about finding the volume of a solid of revolution. Let me read the problem statement. Find the volume of the solid generated by revolving the curve y squared equals 6x about the x-axis between x equals 0 and x equals 4. Let's visualize this problem. First, I'll draw the coordinate system and plot our curve y squared equals 6x. This is a parabola opening to the right. The region we want to revolve around the x-axis is the part of this curve from x equals 0 to x equals 4. Now, let's visualize what happens when we rotate this region around the x-axis. As we rotate this region, it sweeps out a three-dimensional solid. This is the solid whose volume we want to find. We can think of this solid as many thin disks stacked together. Each disk has a radius equal to the y value of our curve at a given x. To find the volume of this solid, we'll use the disk method. The disk method states that the volume is given by the integral from a to b of pi times the radius squared dx. In our case, the radius of each disk is equal to the y value on our curve. So we need to express y in terms of x. From our curve equation, y squared equals 6x, we can express y as y equals the square root of 6x. Now, let's set up our integral. The volume equals the integral from x equals 0 to x equals 4 pi times the radius squared dx. The radius is y, which is the square root of 6x. Substituting, we get the integral from 0 to 4 of pi times the quantity square root of 6x squared dx. Simplifying under the integral, the square root of 6x squared is just 6x. Now, let's evaluate the integral. The integral of x dx is x squared over 2. Evaluating from 0 to 4, we get 6 pi times the quantity x squared over 2, evaluated from 0 to 4. This is 6 pi times the quantity, 4 squared over 2 minus 0 squared over 2. Simplifying, 6 pi times 16 over 2, which equals 6 pi times 8, giving us 48 pi.